Alright, it's my weekly I must record chapter again because the darn recording failed upstairs. Alright, this is Ken Dewey, and I'm recording chapter 2 for the script programming class, and I'm going to show you, first of all, what your assignment looks like for this week. Now, I've already written it, but I can't show you my code because obviously I'm I'm recording, and you would just copy it. Alright, hopefully I don't keep coughing all day. Sorry about that. Okay, your program, first of all, let me show you what it looks like. Here's the output of the program. Okay, it'll ask how many blocks, and I say 4. How long are the sides, and I say 50. That's in pixels. So it outputs, actually this example is 5. Whoops, sorry. Oh well, I copied the wrong picture in there, but this example would be 5 blocks and 50 each. You'll see they're sorted or centered horizontally. I will fix that picture. Here's another example, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, this one's correct. 14 blocks, 30 pixels each. So that's what your program's supposed to do. Ask for the number of blocks, ask how long the sides are, and then output it centered horizontally on the screen. Alright. Now let's get back to talk about what we're supposed to do. It says write a script that takes the following input: how many blocks, how long are the sides, obviously they're squares, so if one side's 50, all 4 sides are 50. It says using the above input, draw the number of blocks on the screen where each side is length specified above. The blocks should all be touching, they should be centered in the turtle graphics window like I showed below. Okay, the entire script including the main portion and methods must be in one single file, and the file name should be like this. Okay, your name, CIT1203. Okay, here's the methods. We've got 2 methods. We've got draw square. Draw square receives the following objects as arguments: an instance of the turtle, the length of one side, and the x and y coordinates. Okay, so this method should use a for loop to draw the equally sided sides. Now, we actually wrote draw square already in the class. It was in chapter 1, so you can use that. It is modified a little to take some additional arguments, but for the most part it's the same. It says this uses set set x and set y, which I will show you where to get information about that, to set the starting positions of the blocks. Okay, then also use the draw block method. The draw blocks again receives the turtle, number of blocks, and the lengths of the sides. Okay, again, it uses the loop to continue for the correct number of blocks. Then this method just calls the draw square method. So if I said 4, it would get 4 here, plus the length of sides I got input. That information would be passed over here to this guy, and then we would end up with 4 blocks. Okay, so it's called draw square from inside the for loop, and should set the position of the next block using go_to. And I'll show you how to do that. The main part of the script should get input for the number of blocks, input for the size of the blocks, which I showed you at the top. That's actually this part right here. Then it should draw a turtle, declare a turtle, set the starting position, okay, with the turtle to center the output, then call draw blocks. So really, this is all the main part of the script does. This can either be above your methods or below your methods. It doesn't matter. Okay, so actually it should be below your methods. That's right. It has to be below your methods. Right. Disregard what I just said other than that. It has to be below your methods. So set the position of the turtle to center it, and then call draw blocks. And that's all there is to it. Okay. It's due on September 7th. And if you actually let me bring that up. It's due on September 7th. If you go to the content page, you will see under chapter 2, you'll see your assignments there. Under the Dropbox, you'll see assignment 2, and is due September 7th. Okay? Alright, that should be good there. Now, let's start off with the program here. Okay, I'm going to actually close this out. We'll start off with chapter 2. Now, they call this Python, as in like pi, for calculating the circumference of a circle. I'm only covering portions of it. I'm not going to go through all his examples. So, If you feel sad about that, well, you're welcome to do them yourself. Alright, hopefully everybody knows what pi is. It's yummy. But here's what pi looks like. Okay, he gives you a couple different ways to calculate it, which actually we're going to do. Which I'm going to show you right here. There's a reason I'm showing you these. Now I'm going to move this off to the side just so we can show you. So 22 divided by 7, 355 divided by 113. So these are all approximations of pi, and you'll see they're very close. They're just not perfect. Now, the next one he does, 9801, parentheses, and I'm sorry, divided by, parentheses, 2206, math.square root 2. Now, I realize I skipped the import statement. I did that on purpose. Reason is, if I try to type this statement, it's going to say, whoa, what is this math.square root thing you're talking about? Okay, math has not been defined. Just like we had to import turtle, we need to import math. So I'm going to import math. I'm going to take the math method and bring it into our program. Now I want to bring this back down here again. I don't want to type that again, so you just click up on the line and hit enter. It brings it down there for you. And then it will output the result. So, just like we imported turtle, you need to import math. Okay, pretty simple stuff there. Okay, let's continue on. Okay, more about the math class. If you want to find out help about it, it's pretty cool. You just type help and then type math. Pretty simple stuff. Now, you can actually, I know it's hard, it's not quite all the way on the screen, but it's close enough. You can go back up and down, and you can see it's got everything. Hypotenuse, F mod, it's just got tons. There's a lot of math. Wow, it's even farther than I expected. Cosine, tangent, just everything. Degrees, exponents, square root. Okay, so it just does a bunch. And I just typed, see there's the square root one we just used. This is returns the square root of x. Okay? The square of x, not square root. Alright, so the math is pretty darn handy. Now, remember when I told you need to use set x and set y? Well, I'm going to type help for turtle. Here it comes. Wait for it. There it is. Okay. It's actually defined in this file here. But if you were to scroll way up here, wow, there's a bunch of them. Well, there's the math. Well, hell, I don't know where turtle started. Where's turtle at? I don't know where turtle started. Well, it's in there. The set X and set Y is in there. There it was. I saw it. There. Oh, there's sets. That's not it. Start X, start Y. You can actually lift your pen up, and you can change the color. There's the go to. I told you need to use go to go to a specific position, and it takes two arguments, X and Y. There's also set position. There's go to again. So you can look through here, and you can also go on Google, type Python set X. Boom, chose it to you. Pretty simple stuff. Okay. Alright, and I just went into Google, typed in Python set X, and you actually see there's some documents right here under Python. And if you go to them, it goes right into it. And if you scroll on down, it even tells you right here, set X. Okay. Pretty easy stuff. Takes an integer for the X coordinate. Hopefully you guys all know what X and Y is. All right. So that's how you find out help for something. Okay, so we looked at the help for math. Let's continue on. We already talked about the help for turtle as well. He starts going into Archimedes' approach to working on circles. I'm not covering that, okay? This is not a geometry class. It's not a math class. We're here to learn about Python. So we're going to be talking more about Python. Okay. Here's what he does for calculating it for pi. I'm just not going to go through that at all, okay? But he does talk about something here which is kind of different. He talks about a function rather than a method. So far we have used methods. We use the draw square method. Well, there's a difference between a function and a method. Okay? A method does something. A function does something and returns a value. You'll see this function right here defined with this name and these parameters returns something. Okay? So a method does something. A function does something and returns something. It actually returns one item. It could be one object, it's just one item. Okay? So that's really the difference between the two. You see, his Archimedes method here actually returns pi right there. Okay, let's continue on. There's more examples of it. Okay, accumulators. Okay, we're going to go to the next page in our book, which should be 55. There it is. Okay, accumulators. What they're doing here is all accumulators is something that adds up, accumulates. Okay. Here he's setting accumulator to 0. Again, he's at the Python problem, setting it to 0. Then he's using a for loop to, for x from range 1 to 6. Remember we talked about start, stop, and step? Well, if you only specify one thing, it's the stop position. If you specify 2, it's start and stop. If you specify 3, it's start, stop, and step. Okay? So since we have 2, the start is 1, the stop is 6. So it's actually going to stop 1 less than 6, so it's going to stop at 5. Remember, the stop is 1 less than the stop value. So it'll go 1, 2, 3, 4, 5. Make sure you put your colon there in the end. I keep forgetting that. But what he's doing here is he's just adding up the numbers. Remember, accumulator starts at 0. For this loop, it's saying the accumulator is now equal to the accumulator plus x. So x is 1, x is 2, x is 3, x is 4. And they all end up adding up to 15. And you'll see here he types accumulator and it gives him the value of the accumulator, which is 15. Okay, pretty easy stuff. All right. Now let's continue on. You can do the same thing here. You could actually very easily modify the loop to do even numbers or odd numbers or whatever you want. I'm just not going to walk through them. Okay, he gives us the next formula, which we are again going to skip. But we are going to get down here to a couple things that are important about Python. Almost there. We're getting close. Don't think I'm skipping. I'm actually skipping some of the math function he's writing. Okay. Okay, that's all I'm skipping is the math functions and circle functions. I'm actually getting. There we go. Now I'm going to get into the next part. The Boolean expressions. Okay, Boolean expressions used in all languages. And let's do a couple examples like he has here. So he's saying, let me get this over to the side so we can see both at the same time. Wow, it's long. Let's get, there we go. All right, so if I type 6, you get 6 because the value of 6 is 6. If I type 4.5, you get 4.5. If I type true, you get true. If you get false, you get false. Okay, so it's just showing you the value of something. Okay. Boolean is either true or false, yes or no, 1 or 0. That's all it is. It's a primitive data type, true or false, and they're used along with relational operators. Okay, which is the next section. It's actually very important. So I'm going to bring that up real quick. Okay, here is the relational operators. Okay, relational operators are less than. The way I remember this is the pointy end points at the smaller end. So less than is pointing at the smaller piece. Okay. Then we have less than or equal to, greater than or equal to, is equal to, or not equal to. Let's walk through some of these examples to see exactly what they do. Okay. So I said 6 is less than 10. Obviously the answer is true because 6 is less than 10. Now if I said 4 is not equal to 4, the answer is false because 4 is equal to 4. Okay. Then apple equals 25. Oh, that's not an equal, that's a 2. Equals 25. Now, it really is not going to do anything there because we're using a single equal sign. So that's an assignment operator. So what we just said was create a variable called apple and assign the variable apple the value 25. Then apple equals 25 is now we're using the relational operator. Is apple equal to 25? So yes. So what if I did this? Apple equal 45. It should be false because apple is not equal to 45. Apple is 25. Okay? All right. Now, we can also do apple equal to 5 times 5. What it's going to do is it's going to evaluate the expression on the right, get 25, then see if apple is equal to, and it should be true. Very easy. So those are some very basic relational things. Now, let me see something here. Okay. No, I didn't know if you could do that in Python. Sorry, I was just testing something. All right, let's talk about some compound expressions. Now, there's something called and or. Okay? For and to be true, both sides must be true. So x and y must be true for it to be true. Okay? It says if x is false, return x, otherwise return y. Okay? So basically, ands, they both have to be true. An or, either one of them can be true, and a not, it just reverses it. So let's look at an example over here. Okay? So if I said 6 is less than 10, we know that's true. Okay? But what if I said 6 is less than 10 and 3 is less than 7? Is that true? What's going to happen is it's going to evaluate them both. 6 is less than 10 is true. And since we have an and statement, they both must be true. So the 3 is less than 7, which is also true. So the answer is true. Okay. Now, I talked about it in class, and I also talked about in some of the other recordings, well, in other languages, about shortcut notation. All right. I keep thinking back to the Apollo 13 movie. I don't know why I do, but I do. Because what happens is, when we're running this thing right here, okay, remember, with this and, both sides must be true. So if I said 6 is less than 10, so far we're true. That's good. So then we're going to check the right-hand side, make sure it's true. And as long as they're both true, the answer is true. Well, does it really work that way? What if I did 6 is greater than 10 and 3 is less than 7? Okay. Is 6 greater than 10? The answer is no. The answer is false. So what happens is our compiler looks at that and says 6 is greater than 10, false. Then it sees the and. Then it's like, whoa. For an and, both sides must be true. Since I already have a false, it doesn't even check the right-hand side. Okay? So basically it stops. It says 6 is greater than 10, false. I have an and, quit. Doesn't even bother to check the right-hand side. That's the way it works. It's fine. Computers are very logical, but I do have an issue with that. Like in Java, you know, you can prevent that by putting a and sign or single and sign. But the reason I have an issue with that is, say I'm in a hospital, and you know, as long as I'm breathing and awake, I'm alive. But what if I'm sleeping? You know, I would just rather them check both sides. That's not how it works, so it kind of sucks. It doesn't mention it in your book. It's not going to be on a test anywhere. It's just my 2 cents. You know, it's like shortcut notation tells it, hey, once you find a false, you don't need to check the other, which is totally correct. But if it came down to me and it was my life or something, I might say, you know, I realize my heart rate's 0, but maybe the machine's broken. Why don't you actually touch me and see if I'm really alive, you know? That kind of stuff. So, all right, that's just my 2 cents. All right, so let's continue on. So that one should be false, and it is. Here we're saying 4 is not equal to, not $, 4 is not equal to 4. Okay? And that should be false because 4 is equal to 4. We actually proved that up above. So 4 is not equal to false, or 5 is less than 8. Okay, so 4 is not equal to 4 is false. We know that because we saw that up above, and I just showed you again here. But 5 is less than 8 is true. So with an or statement, one or the other needs to be true. That's all. So 4 is not equal to 4 is false. 5 is less than 8 is true. So we have false or true. So the answer is true. Very, very easy. Okay. Now the next example up here, 6 is less than 10, and 10 is less than 6. Obviously the second one's wrong because 10 is not less than 6, so the answer is going to be false. Now if we say not, 6 is less than 10, what it does is it takes the expression 6 is less than 10, which is true, but it uses not along with it, so it ends up negating it, so we end up getting false. See, in other languages you can just write the explanation point like I did up top. But this one doesn't like that. So, alright, let's continue on. Okay, selection statements. Alright, selection statements are if and else statements. Actually, I had a little issue up in the classroom with this, but I'll tell you about it here in a second. But the way this works is if this first condition is true, then do this. Okay? So if the condition is true right here, then do this right there. Or else, if this condition is not true, then do this. Okay? So it's either one or the other. If and else. If the first condition is true, do the first statement, or else do the second statement. Okay? Here's the way you can look at it in a flowchart. So come on in here. We have a condition. If this condition is true, we do something, or else it's false, we do something else. That's exactly how it's written. Now we can also, let's actually put this in the compiler here real quick. Okay, A equals 5. Okay, B equals 3. If A is greater than B, colon. Now you'll notice it actually indents at that point. C equals 10. Okay. So if A is greater than B, C is equal to 10. Now to put an else statement, I actually have to hit the backspace key. Else C equals 20. Alright. 1 second. Alright, so when I hit enter here, now it's going to, take that statement. Now if I hit enter again, I'm back to the point. Now, remember, A is 5, B is 3. I said if A is greater than B, so if 5 is greater than 3, then C equals 10, or else C equals 20. Okay, so I want to know what the value of C is. C is 10. Okay, but what if I did B equals 8? Okay, now if I just type C, you would naturally think that C is equal to 20, but it's not. The reason is I have to tell it to do this statement again. This is an interpreter. That's actually cool. I type that and it just puts the whole statement in again. Now when I type C, it works. Because this is an interpreter, not a compiler. Because when I went over here and just said B is 8 right there, that's fine. It did replace the value of 8. But this statement had already been processed in memory. It does not reprocess it until I type it again. So, that's why I did B is equal to 8. I did C10. C is 10. Because this hadn't processed yet, I tell it to process it again. And then C becomes 20. Pretty basic stuff. Okay. That's an if-else statement. Okay. You can have more than one statement. Actually, let's do more than one. So I'm going to go in here. I'm going to bring this down. And I'm going to go up here and say Z equals 4. And I'm going to go over here and say Z equals 5. Okay? So now, let's... So if A is greater than B, first of all, I need what A is. A is 5. So C is 20. Because A is greater than 5. No, I'm sorry, A is 5. And B is 8. So 5 is 5. Okay, 5 is A. I'm so confused now. Actually, let me put them both back in here. A equals 5. B equals 8. Let's put this statement back in here. Alright. So now let's run it. So now we get C of 20. So A is 5, B is 8. Is A greater than B? Is 5 greater than 8? No, it is not. So C becomes 20. if it was, then C would be 10. Now, you notice I actually have two statements in here. I can actually type Z to find out what the value of Z is as well. You can have more than one statements, but they all must be indented the same. Okay, that's what they talk about there. Actually, we just did that. We can have if inside of an if. We can have if inside of an else. We can have an if-else inside of each other. It's not a problem. You just embed it inside of each other. That's all there is to it. You have an if and an else and an if and an else and an if, and you can keep going forever. And you can also have else if. For instance, if A equals to 5, else if A equals to 6, else if A equals to 7, so on and so forth. You can do that. Okay, fine, I'll do it for you. So if, we'll just say A equals 5, L5. Actually, I did that wrong. Look at this. If I do this, what's wrong with that statement? Okay. It doesn't like it because remember, a single equal sign is actually an assignment operator, not a relational operator. In Java, it'll actually take that, which actually causes issues. A equals 5. Okay. So if A equals 5, we'll say C equals 10. Now, I'm going to hit the back arrow. I'm going to go elif. Now, if you do else if, it's not the same thing. It's elif. I thought it was all one word at one point, but it's not. It's elif A equals 6. Oh, you know what the problem was? I forgot the darn I forgot the colon. A equals 6. Okay. C equals 11. Man, I can't write that. A equals 7. C equals 12. Okay, now I can just do an else. C equals 13. Alright, so what's the value of C? It's 10 because somewhere up here A was equal to 5. Okay, so that's an if, else, else if. We did all that there. So, alright, let's continue on. Alright. Now, random. Yes, we must talk about random. Alright, let's type random here. Print, I'm not going to do his whole thing here, but print random dot random. Alright. Random, first of all, there's no such thing as a random number. Everything is based upon something. Even a computer uses a seed, which is normally the processor. But I told them about in class. I was watching this video, this statistics video, about a guy who tested casino machines. His job was to test them and find flaws in them. And then obviously if there was flaws, he would report them and get them fixed. Well, he was testing a Keno machine, and he found a flaw. He found a flaw in the random number generation component of it. He found that if you do a certain thing, you can very precisely predict the output. So rather than turning it in, he actually told all his buddies about it. And what did they all do? They all went to the same casino at the same time, played, and all won, and all got arrested. Pretty stupid. They should at least go on to different days or different casinos or something. Alright, so let's talk more about this random. First of all, it doesn't have a clue what I'm talking about. Reason is, once again, we need to import it. Okay, import random. Now, we can print a random number. Okay, if I keep bringing this up here, you'll notice we keep getting a random number. Okay, now you notice the number is always 0 point something. Okay. The reason is the random is a number between 0 and 1. Okay? That's all it is. So the random number is between 0 and 1. So what would happen if I took this and multiply this times 10? Okay? Still not what I want. Okay? There we go. That's what I want. Okay, now you'll see the number is much higher. It's actually between 1 and 10. But say, I'm rolling dice. Can you imagine going to a casino, instead of having dice that, had 1 through 6 on them, they actually had decimal places? Wow, that would suck. So how do I make this statement right here show me whole numbers? Well, you're going to need it in your program. You're actually going to need it on the part where you're getting the number of blocks. To do that, we use what's called typecasting. We actually talked about it before. Now this is going to give me an error. I'm going to show you the error. If you do this, what it's going to tell you is int random. It can't do anything. It doesn't know what the heck I'm talking about here. So what I need to do to fix this, I need to say integer, but I need to take this entire mathematical equation. So what's happening is this whole ending part, that part right there, is then converted to an integer. So now if I run this, you'll see I get a nice whole number between 0 and 9. Isn't it nice? And you can multiply times 100 if you, well, bring it back down here, do it times 100 if you like. So you can very easily, now you know how the lottery works. You just change the numbers. Okay, pretty simple. Alright, so that's random. Remember, to get all this to work, I had to import random right there. You're not requiring random on this next program, but you will require this int. You will be using random later on in the class, though, so I just wanted to cover it for you. Well, hopefully you all saw that, because it was kind of off the screen a little bit. But yeah, with hundreds, you could very easily, see that there. Okay. So there's random, and he uses in a program for a number of darts. And I'm not going to walk through his example. Just about finished. Actually, I think we are finished. Yeah, he talks about adding graphics. Okay, he covers more of the turtle stuff. He's actually going to draw you a picture here. I will show you. You can actually do different colors and all that. We're not going to do that today, but you can do it. And we will be adding pictures later on. So I just, we're just not doing it right now. And I think that's about it for this chapter. Yeah, we pretty much covered all this stuff again. I'm not holding you responsible for all that, all the mathematical functions. So don't worry about that. All right, that's all for chapter 2.